For decades, the way we've managed our most critical networks hasn't really changed. It's been a person, a keyboard, and a whole lot of manual typing. But here's the thing. As our systems get ridiculously complex, that old school approach, it's not just a bottleneck anymore. It's becoming a huge business risk. Let's dig into why. So let's meet Bob. He's a lead network engineer at Acme Corp. And right now he's having a really, really bad night. He's in the middle of this super important migration and, well, it's all going sideways. Connectivity is down, the phone is ringing off the hook, and Bob is scrambling to figure out what went wrong. And his story, this absolute nightmare he's living through, it's a perfect window into a much bigger problem we see all over IT. So what exactly went wrong? I mean, Bob's a smart guy. He had a great plan, a solid architecture, but the second it hit the real world, it all just fell apart. Let's do a little postmortem on this network train wreck. Yep, you're seeing that right. The culprit was a single copy and paste error. After all that work, all that planning, the whole network went down because a colleague, let's call him Larry, just missed a couple of characters when he was pasting in a new config. A simple, totally human mistake made under pressure, and boom, massive outage. It just goes to show you how fragile these manual processes really are. Look, Bob's terrible night wasn't just a case of bad luck. It was basically bound to happen. And here's why. First off, we're human. We make mistakes, right? Especially when we're stressed. And a tiny typo can have a massive blast radius. Second, we're just slow. Going box by box with the command line, that just doesn't scale in today's world. And third, and this is a big one, Bob had no way to test his full migration, or even more importantly, his rollback plan. And all of this creates this nasty, self-reinforcing cycle. We're scared of making changes because they're risky, so we do them less often. That means each change becomes this huge monolithic thing, which, you guessed it, makes it even riskier. Okay, so this whole situation brings up a really interesting paradox you see in a lot of IT departments. In every story you've got a hero, but in IT, sometimes that hero is also your biggest bottleneck. A consultant, Rita, she saw this firsthand at Acme. Anything critical to the network, it all had to go through Bob. Need a new virtual network? Gotta ask Bob, he owns the spreadsheet. A high-risk security change? Bob's the only one with the tribal knowledge. The CIO needs Wi-Fi at her lake house? You get the picture. Ask Bob. He's the hero, for sure, but that also makes him a single point of failure, and that was actually holding the entire business back. So this whole hero bottleneck thing perfectly illustrates the shift we really need to make. For like 30 years, we've been using the command line, the CLI, to manage networks. It was designed for humans to type into, which means it's manual and it's super prone to error. The future? It's the API, the Application Programming Interface. That's designed for machines. It's automated, it's consistent, it's repeatable. To put it simply, the API is the new CLI. Okay, so how do we actually make this jump from the old school CLI to the modern API? The answer is this really powerful idea called infrastructure as code. And the name says it all. You stop thinking about your network as a bunch of physical boxes and start treating it like a single piece of software. And the cornerstone of this entire approach is something called the source of truth, or SOT for short. Just think of it like the master blueprint for your network. It's the one central place that has all the data defining exactly how your network is supposed to look and behave. I mean, if a meteor wiped out your data center, you could rebuild the whole thing perfectly just from this one source of truth. That's how powerful it is. Now, this is a huge mental shift, right? You're no longer wrestling with thousands of individual commands on hundreds of different devices. Instead, you're just managing one single, centralized set of rules, a data model, that describes the whole network. It simplifies things radically. So what does that actually look like? Let me show you. On the left, you've got these complicated vendor-specific commands just to set up a basic network connection. In this case, it's something called BGP peering. It's how different networks chat with each other on the internet. It's a mess. Now, look at the right. That's the model-driven way, using a standard language like Yang. See how clean that is? It's just simple, human-readable key-value pairs. This common language just hides away all that crazy complexity. All right, so we've got our blueprint, our source of truth. Awesome. But how do we actually apply changes from that blueprint to the live network without, breaking everything? Well, that's where the automation pipeline comes in, and we're borrowing this idea straight from the world of software development. So check this out. Here's how it works. An engineer wants to make a change, so they just edit the source of truth. That one action automatically kicks off this pipeline. Instantly, a virtual copy of the production network is created. The proposed change is then tested like crazy against the simulation. We're talking syntax checks, compliance validation, even functional tests like, can this server still ping that server? And only, only when every single one of those tests passes does the change get the green light and get deployed automatically. Now, just stop and think for a second what this would have meant for poor Bob. Larry's little copy-paste error, it would have been caught immediately by an automated syntax check, dead in its tracks. And Bob's risky, untested rollback plan, he could have run the entire migration and the failure scenario in a totally safe virtual sandbox. He would have found the problem hours, maybe days, before it ever touched the live network. So you can see this model-driven DevOps approach isn't just about avoiding disasters. It's much bigger than that. It's about fundamentally changing IT from a cost center into a real engine for business growth. And the benefits here, they're absolutely transformative. You get a huge boost in agility. You can respond to what the business needs in minutes, not drag it out for weeks. Your reliability goes through the roof because every single change is validated before it ever goes live. And security and compliance, they're baked in from the very beginning, not just tacked on as an afterthought. And this next point is really, really important to get. This whole thing is not about replacing engineers like Bob with robots. Not at all. It's about taking all of Bob's incredible knowledge and expertise, capturing it as code in that source of truth, and then scaling it across the entire organization. It frees up brilliant people like Bob to stop constantly putting out fires and start designing what's next for the network. So, let's wrap up with this thought. Once you stop looking at your network as just a pile of boxes you have to manage one by one, and you start seeing it as a single programmable platform, suddenly a whole new world of possibilities opens up. The question isn't just, how do I fix what's broken anymore? The real question becomes, what are you going to build next?